Okay, so in today's lab, you have to practice the WCF service instancing and concurrency concept that we have covered in the class. That you have to try out the different combination of service instance and concurrency mode. And for each combination, you have to verify the output whether on the service side it is able to create the how many threads depending upon the selection of the concurrency mode. Similarly, you have to also check whether the instancing mode like per call, per session or single, how does it affect the number of instances on the service side. And you also verify that if we change this instancing mode, do we require to recompile our host or client application? So see that, do we need to compile the host application or client or service? Out of the three application, which one we need to recompile in case if we are changing the instancing mode? Okay, so basically we are using that instancing mode as part of the service attribute, and by changing it we can specify whether it should be per call, per session or singleton, right? So I think you have the sorry, I think it is MEMS lecture. Please, we have the lab at okay, fine. So we have the lab at 3:30, not right now. Okay, so I mistaken. I was thought that it is at 1:30. Okay.
No problem.
Okay, so we'll have the lab at 3:30. I just mistaken that. Okay, I'm leaving.
Okay. So read the first question and tell me what should we write. So it is given that UDP is transferring a file of some bytes. What is the sequence number of the datagram if this data is to be sent in 3 datagrams? Like 5400 bytes are there and it has to send in 3 UDP datagrams. So what is the sequence number that is given? And there are some options. So 2 of you are saying that 0, 1800 and 3600. What about others? Shall we quickly recall UDP? Tell me the characteristics of UDP. Yes, it is connectionless. Then it is unreliable. What is the purpose of sequence number? Why do we have sequence number? Yes, Aditya, you are right. Sequence numbers are used to ensure reliability. Like if at all your data is delivered in the wrong order, then they can be reordered. And if some of the packets are missing, you know which are retransmitted. and accordingly you can fill the gap at the receiver. So no Dev, no sequence number will be used in the UDP. And even otherwise, say we emphasized so much on the header. What was the UDP header made up of? Source port address, destination port address, length, and checksum. That's it. Was there any provision for the sequence number? No, there wasn't, right? So none of this is the answer in this. There are no sequence numbers used in UDP. No retransmission timers, no retransmissions, no acknowledgement. Checksum is optional. Checksum is optional. You may use it, and that is just for the purpose of obviously not delivering the wrong data. Like if the data is very wrong, then that can be avoided. However, if it is wrong, then we are not going to attempt retransmission or nothing. Just it can be avoided. But however, if you're adamant that you don't want to, use it, then you can fill all the bits to be 0 and it will not be there. The next one, there is no outstanding acknowledgement in TCP connection. That means all the packets which you sent have been acknowledged. The sender sends 3 segments back to back. Which are the sequence numbers? They are given 2210, 2260 and 2390. The first segment is lost. Second and third are delivered to the receiver. And now here there are 2 variables defined, P and Q. P is the amount of data in the first segment in bytes. And Q is the acknowledgement number which is sent by the receiver. Once we know that, we will be able to find out Q minus P. Can you help me find out what is the value of P and Q? What will be P here? P is 50. And Q, what about Q? What acknowledgement is sent by the receiver in TCP? In general, I mean in this, not in this, in general, what will you write in the acknowledgement number? Yes, the next byte which you are expecting, sequence number of the next byte expected by the receiver. So because the first segment is not delivered, it is still expecting starting from 2210. So you are right. 2210 is the value of Q, and that is 50. P is 50, Q is 2210, and you can take the difference and that will be the answer here. So what would that be? 2160. I think many of you have got that correctly. This is the correct answer in this one. I hope all of you understand that. So in case if you are required to explain that, you should be able to do it. Now, some of you might have taken GATE exam. One student met me as well. So it was allowed for the pre-final year students. And you might have observed that there was significant weightage of computer networks. And in some subjects, like if you are talking about operating system, then from operating system, there will be one question from the scheduling algorithm. While in CN, it isn't so predictable. It could be from any of the topic. But if your concepts are clear, I believe you should be able to attempt that. How many of you have taken the exam? Okay, Aditya, Devansh, Dev, nice. Shail. So, did you find the paper interesting? Or lengthy or difficult? If you have to describe it, how will you do it? How did you find the examination pattern and all that? Yes, Shell, it has started from last year, MSQs. It has started from last year. But I think if your concepts are clear, we shouldn't worry about that because in a way it is not contributing in the negative marking. So if your concepts are well, you're bound to get the marks without any scope of losing it. But if you're using the elimination method or trial and error, then it might not work for you. So MSQs were there. Apart from that, others, how did you find it? Most of the questions will be concept based. Your observation is right. Only some of the questions will be information based, like we just require you to remember a few things. Only a few questions will be like that. So that is true. It was difficult. Yes, it might be difficult for some subjects. I think of the TOEFL as well, you should have been able to attempt some of the questions which you are learning this time. So there are two things I think which you need to pay attention to, those who are going to target GATE seriously. Yes, CNOS, DBMS, TOEFL were in majority, apart from of course your DA and DSL, that would be there. This time there was very less weightage of DDC, just one question, and that too not to, which they have been asking so far. Anyway, so speed and accuracy, these are the two things which you will have to work for if you are targeting that seriously. Like many of you might have known the answers. Instead of 3 hours, if you were given 6 hours, then you might have scored probably much better than what you would be doing now. But in the limited time, you will have to understand the question, attempt it, and avoid the negative marking as much as you can. So I said this because there were, I think, 1 or 2 questions related to transport layer as well. There was one question related to sequence number, reuse, which you might not be knowing as of now. And there was one question like distance was given between 2 points and speed was given, and you were to find out that how much time will be taken by the data to be delivered. Do you remember that? Could you attempt it? No? Okay, we will solve one such question then. So in such questions, rather than focusing on the memory, we should be focusing on the concept and try to understand that. So let us go for this one. The bytes of data transfer is in each connection are numbered by TCP. The numbering starts with a 0 or 1 or randomly generated 16-bit number or none of this, or depends on the size of the MSS. Chanel says none of this. What about others? Priyank, it is not just plain random generated, it is random generated 16-bit number. But in TCP, the sequence number will be 32 bits. So, yes, Ansh, that is true. So it will be none of this. That would be the answer of this question. It is randomly generated. If it is just written that numbering starts with a random sequence number, then that would be correct. Then you would be right. But here it is categorically written, which is wrong. So we'll have to not opt for that. A value in the acknowledgement number is a number, yes, of the next byte of the next byte. Okay, here T was missing. Byte it expects. It means who expects. Here it is used for receiver. True. Fine. Now you will not be answering. Please, I would like some others to contribute. Value of window size in TCP header is determined by, there are some combinations given. 1 to 10 roll number. Anyone from 1 to 10, please? Receiver? Priyank says receiver. That is true. Isn't it? Say if any one of you is not understanding the answer, and if you have any other different answer, feel free to let me know. Otherwise, we'll be going ahead quickly. The next one, 11 to 20. Inclusion of checksum in UDP header is, and there are options. Mandatory for data segments, optional for acknowledgement, depends on the application, optional, compulsory, none of these are recommended by research community. What do you think is the correct answer? Optional. Yes, Kevin, you are right. The next one, 21 to 30. 21 to 30. To accomplish flow control, TCP uses limited size window protocol, sliding window protocol, fixed window protocol, none of this, or smart window protocol. What is used by TCP? (21 to 40). up to 50. Anyone? Yes, it is sliding window protocol. That is true. It is sliding window protocol. The next one, which of the following are not valid options for TCP? 4, 6, 8, 16, 24. What size option should not be used by TCP? 21 to 50 again. So what would be the correct answer here? Anyone from 21 to 50? Keval says 4 and 6. What about others? Okay, 51 to 60. Not valid options, huh? Vimal says 4, 16 and 24, they are not valid. Or they are valid? Channel says 4 and 6. Everyone, tell me, what is the size of compulsory TCP header? 20. That is true. And if it's not bits, bytes, 20 bytes. If it is 20, then what will we write in the header length? What will we write if the size is 20? How do we scale it? You write 5. That is true. You divide by 4 and you write 5. That is true. That means your header should be multiple of 4. Then you will be able to write it in the header length. If it was multiple of 8, then 20 would not be possible, isn't it? And how many maximum options are possible? Maximum options are possible? Not 15. Come on. I mean, okay, the value is 15. That is true. The value in the header length is 15. 1, 1, 1, 1. If it is 15, that means 15 into 4. That means total 60 bytes. Out of 60, 20 bytes are for the compulsory header. So options will be of maximum 40 bytes. Maximum options can be of the 40 bytes. So even if I write here 44, then even though it is multiple of 4, it would be incorrect because that will not be possible, right? The size can be minimum 4, maximum it can be 40, then 4, 8, 12 and so on. So can you tell me which one of this is not valid? Yes, 6 would be the correct answer here, right? Now see, sometimes it is not necessary that you will be needing in the multiple of 4 only. You might need to write the option of 6 bytes. That is a possibility. But if you have to write 6 bytes, then 2 bytes you will be going for no operation. Those are kind of padding options or stuffing options which are given to make the boundaries of 4 bytes. So in no scenario, you will be having anything other than multiple of 4. Some of them might be like no operation could be appended, or the last operation, end of operation could be there. But along with that, it has to be in the multiple of 4. The next one, which is not valid for UDP, tell me. There are some characteristics given which are not suitable for UDP. Sixteen should not be valid. 16 is a valid answer. You can have options of 16 bytes. Priyank, you can unmute yourself and ask me.
Hello, ma'am.
Yes.
Means 4 is the I am telling that 4 should not should be valid because 4 into 4 it is 16, but minimum header length is 20. So
no.
how?
Here, see. Which size of the option is not valid? It is not given header length. We are talking about exclusively options, not the header length.
Okay.
Is it okay? So if I give you that what value, again, if I say size of the header, then I'm talking about explicit size. If I'm talking about value in the header length field, then we will have to multiply that by 4 and then you will examine whether it is okay or not. Okay. The next one, connectionless, fast, less overhead, unreliable, use of port address. Which one of these is not applicable to UDP? None of this, or rather all of these are applicable, right? I mean, my correct of this question, the answer is none of this. That is true. But what I was saying is which one of this is applicable, then all of these are applicable for UDP. It is connectionless, it is fast because there is no overhead, less overhead, it is unreliable, and port addresses are used by UDP. So none of this would be the correct answer, which you would have written. The next one, TCP is transferring a file of 5554 bytes. The first byte is numbered this. Okay. What will be the number of first segment if two segments are of the same size sent? Like this is the data which you are supposed to send. It is divided into two same sized segments. That is what is given to us. Then what will be the number of the first byte? What will be the number of the first segment? Sorry. What will be the number of the first segment? Yes, 1055. I just wanted you to have 1 mark. Yes, 1055. You didn't need to think anything about this. If I tell you that what will be the sequence number of the second byte, then you will have to think and tell me. So answer of this is 1055 only. You are right. If the question was what is the sequence number of the second byte, can you tell me what it would be? Others? It is okay to use calculator or pen or mind, book, hands. Wait, don't worry. Say I've got 3 answers and all 3 are different. So even though it seems pretty easy, and it is easy, but sometimes in such simple questions we be casual and then end up with the incorrect answer. So Chanel, can you tell me what will be the first byte and last byte of the first segment? In the first segment, what data do we have starting from 1055 to? In Priyank, 2. Janil and Priyank. The first byte will be 1055. The last one will be, yes, Yash and Keval. It will be 3831. It will be 3831. So the next segment will start from 3832. So in case if I just change the word here, second segment, the something is the sequence number of the second segment, then here the answer would be 3832. Okay, the next one. Write down the number of most suitable answer in the given space out of order data processing. Which one of this do you think will come? 2. You're right. Urgent pointer. That is true. Even if I write urgent flag here instead of urgent pointer, then also it would be the answer because it is dealing with that. The next one, which is most suitable for persistent timer? Yes, in case of 0 window size, we start the persistent timer. Nice. So we are going to go with 8. That is true. Please read the 13th, which we have discussed in detail. Error control is provided by data link layer. Error control is mandatory data link layer. Which one of the following is true for the above set of statements? Both are true. It is provided and it is mandatory. A is true. It is provided, but it is not mandatory. Yes, yes. It would be A. Like if this was A is true and B is false. So it is A is true. It is provided at the data link layer for the optimization, not for the necessity. Yes, channel. Is someone unmute here? Nandini, can you come? Okay, no problem. Mute yourself. Okay. The next one. Error control is provided at transport layer. Error control is mandatory at this. So now what is the answer? Both are true. Are you sure? Yes, that is true. Both are true. It is mandatory and it is provided. If I write here, error control is provided at the transport layer and error control is for optimization purpose at the transport layer, then what will be your answer? B would be false. That is true. Fine. The next one. Which one of the following can be used to avoid sending small segments? Clark's algorithm, Jacobson algorithm, Kahn's Silly-Windows syndrome, window scaling factor, Nagel's solution. What will be used so that we avoid sending small segments? (51 to 70). Would you please answer this? 51 to 70. So it is not Clark's algorithm alone. Clark's solution will be used, but along with that, Nagel's solution is also used. Both of them are used for avoiding small segments. The scenario is different in both of them. Like if the transmitter is slow, then it is generating data slowly. At that time, Nagel's solution will be useful. If the receiver is consuming data slowly, then Clark's solution will be useful. But if receiver is consuming data slowly, it is reporting lower memory, and then it is compelling your transmitter to construct the tiny segments. So in both the scenarios, we are generating small segments, and both of these contribute to avoid sending them. So we'll be writing both of this, Clark's solution and Nagel's solution. The next one. It does not add anything more than the services which is provided by IP except providing port addresses. Will it be UDP or TCP or both or any of them or none of them? UDP, yes. So is IP reliable or unreliable? Internet protocol IP, is it reliable or unreliable? IP is unreliable. Okay, IP is unreliable. See, Keval, whenever we say reliability, we will have to have acknowledgements, we'll have to have retransmission timer, retransmission, sequence numbers, everything. Without a checksum as well. Apart from this, you can never ensure reliability. We have to send the data. Receiver has to check whether the data is correct. It has to tell us that data has been received. Then only we are sure that it has been delivered. If receiver doesn't tell us, then we will have to make sure that receiver receives that by the purpose of resending data or whatever. So none of this is provided by IP. There is a checksum in IP header, but that is just of the header. That is just of the IP header. And that is not to ensure data integrity even. That is just to make sure that we are not sending data obviously at the wrong IP addresses. That is the only purpose. In UDP, it is optional. It is with the data and header both. But at the IP, checksum is calculated just over the header. Tell me one thing. The source network layer, it computes checksum. Will it be same throughout the transmission or it will be changing at the routers? The checksum which is calculated over IP header at the source, it will be changing. That is true. It will change. But Kevin and Janil, I have probably a problem with your reasoning. Is it because source is changing? Is IP address changing? IP source address, source IP address, does it change at every router? If let us say we are having A, B, C, D, that is the network. Then IP A is the source and IP D is the destination. While we are sending data, will it change at B and C? Source IP address, will it change? No, it wouldn't. Hana. It wouldn't change. But there is some another parameter which is changing. That is why your checksum will change. So at the data link layer, your source MAC address changes and destination MAC address changes, but not at the network layer. Yes, that is due to TTL. That is true. That is due to TTL, because how many hops are left, that will change at how many hops. Yes. So based on that, it is HOPS. Okay. So due to TTL, because TTL is changing, our checksum will be computed at each router. Now let us think about the same situation at the transport layer. At the transport layer, the checksum is calculated over the header and data. Will it change at the routers or it will be same? You're right. It will be same throughout, because source port address, destination port address, and there is no variable parameter. Nothing will be changed by the routers. And it shouldn't be, because routers function up till network layer. And this is the transport layer. Yes, channel. Exactly. So transport layer is active just at the receiver and the transmitter. So that checksum will be same. Yes, Aditya. So at the transport layer, while we are computing checksum, the transport layer is accessed just by the transmitter and receiver. Routers has no access over the transport layer header. For routers, it is data which it is supposed to deliver. It is payload which it is getting from the upper layer. So actually, you want me to repeat the question? The question was, at the transport layer in the TCP header, there is a provision of checksum. So will that checksum be constant throughout, or it will be changing at every router? That was the question. And it will be same. That is the answer, because transport layer is accessible only at the transmitter and receiver. There is no variable field in the transport layer header. Okay. The next one, a connection is defined by what? The last one actually. This is the last question. A connection is defined by come on, you know this. See, when I say connection, I mean two endpoints which can be uniquely identified. So if I say port address channel, then the only problem is like if I'm talking about 4050 port address, and 4050 can be at the ABCD. If that is our network topology, then it can be on all of them. 4050 can be on all of them. And source is using, let us say, 10,000. So if I say 10,000 and 4050, I don't know what connection I'm talking about, because 4050 is running on A, B, C, and D, all of them. Are you getting what I'm targeting at? Okay. And MAC address is Preet, no. When I say a connection, that means at the transport layer, connection is defined by, like if I'm talking about ABCD, I want something which is unique of A and something which is unique of D, so that I know that where I'm talking about. There is no virtual link, virtual circuit, there is no physical link, and IP address of the end machine and routers. This makes no sense whatsoever. And MAC addresses are just between the, MAC addresses are there. How do you know MAC address of the destination sitting at the transmitter? You don't. You just know MAC address of the next one. Then the next one takes over and it sends to the next one, and so on. So when I say a connection at the transport layer, what we mean by that is the combination of IP address and socket address. If I say that IP A 10,000 and IP D 4050, then I know that I'm talking about that application on a computer and application on computer D. So alone IP addresses are not sufficient, alone port addresses are not sufficient, and scope of the MAC layer is not here. So IP plus port, like two pairs of IP plus port addresses, that would be the correct answer. Or in other terms, we call them socket addresses. A socket address is IP address plus port address. Do you remember that? So if you remember it, well and good. If you don't, please remember it now onwards. The two endpoints are defined by two socket addresses, and that will be unique in the world. Because if you are talking about same two processes on the same computer, like if I'm talking about your computer is having the source and your computer is having the destination, then IP address will be same, but port address will be unique. So that combination will tell you that what you are communicating with. If you are talking to your computer to other computer, then IP address will be different. Port address might be same or it might be different. Like it will be different in most of the cases, but even if it is same, IP address is there to differentiate between these two applications. Please ask me if you have any doubt in this 1 to 17 questions, these questions, and you have scored very nice marks in this. So I wasn't sure whether I should be happy or I should be a little bit concerned that whether you attempted on your own, or I should be glad that you understood everything. So I'll take the safer approach and I'll assume that you are smart and you understood the subject, and that is how you scored very nice marks. But please read the textbook, read the concepts, and the subject is important from many perspectives. I mean, not just GATE examination, but in company while you go, then often you might need to deal with some of the networking modules. Of course, it will not be in this much depth, but knowledge never hurts. And if you're going for security or something related to networking, then without this you will not be able to survive. And in any case, we are learning this subject, then why not to do it properly? So for the last time, do we have any doubt so far? Feel free to ask me if you have any doubt. Otherwise, I think we should solve some questions, at least for the benefit of those students who are proactive and who are interested. So are you ready for some of the questions to be solved? I'll be typing the question here. Please do not write. Okay, if you know the answer, just say that yes. Then I'll ask from them, because we want everyone to have the fair chance. So I'll type the answer here. If you know it, just say yes, please. And then at least we know that how many of you are. And these are not necessarily from my portion. I'm asking in general, okay? And this you have covered so far. This has been covered so far. I'll not read it. You will read it and you will try to think about it. If you know the answer, just write yes or whatever you want to write. Can you read the question? Yes, Nirav, can you please tell me what will be the correct answer in this? D, that is true. What is the purpose of TTL? It is used to prevent the packet looping. Like by chance, if we are having, let us say ABCD, the network which we have been taking, A is transmitter, D is receiver, B and C are routers. Now B is sending data to C, and somehow if C's routing table is corrupted and it is sending back to B, then B will send to C, C will send to B, and forever they will be in the loop. So not only they are busy, but they're also utilizing the bandwidth in between. So what we want to do, that they'll be doing it for some time. When the TTL, time to live, reaches 0, then this packet will be discarded. And please remember that it is not in seconds or milliseconds. Time to live tells you if it is 5, that means it can go to 5 hops. It will visit 5 computers. Then it will have to be stopped. When it goes from A to B, it will be 4. When it goes from B to C, it will be 3. And if it is coming to B, it will be 2. Again, it is going to C, it will be 1. Next time when it goes there, then it will not be forwarded anymore. It will be discarded. It is to limit packet lifetime. Now you will have to tell me answer of this. You know the answer of this? I mean, you just give me the answer. I'm not giving you options here because I know you can do it. I want more people to participate. Abhi, can you tell me what should I write here? For real-time multimedia, what is used? UDP. Then for file transfer? What is used for file transfer? Vimal, can you tell me? TCP. Yes. For DNS? UDP. And for email? For email? Kenil, can you tell me? Kenil will answer. Please, no one else. Kenil, what is used for email? TCP. That is true. So respectively, these are the protocols which are used for these applications. Real-time multimedia, then UDP. File transfer, that is FTP, uses TCP at the transport layer. DNS by default uses UDP. Occasionally it may turn into TCP, but by default UDP is the answer. And emails, that is SMTP protocol, uses TCP. Okay, fine. Please don't see this as an opportunity to know the questions or nothing like that. Let us focus on the fundamentals because all of you have got decent marks. Let us focus on the fundamentals here. You might not know something here. Actually, third and fourth statements you are not aware of. So you will have to just tell me between these two. This we will deal, you know flow control, but you don't know congestion control yet. So these are related to congestion control. My bad, I have given this question. So S1 and S2. Can you tell me which one is true? S1 or S2 or both of them are true? S1 and S2. Okay, Chanel, yes. S1 is true. True. S1 is true. TCP handles both congestion and flow control. S2 is false. And actually S3 is true and S4 is false, but you will not be knowing at the moment. No worries about that. Yash, can you tell me what will be the answer to this? Priyank. Okay, Priyank, you tell me. Yes. Cell window syndrome is related to degradation in TCP performance. So see, actually, you would not have read this exit statement in the textbook, but you know that if there is cell window syndrome, it doesn't cause error. It is not related to file transfer. It could be in chatting or anything. And what is interface problem? I mean, just something unrelated. But it does degrade TCP performance because overhead is higher. So you will opt for this. The last one, this one currently. Yes, Dev, please tell me. Yes, Dev. Love, were you going to say the same? Fragment offset? Okay, great. So we know this much. Now, do you remember stop and wait protocol? Do you remember stop and wait protocol? Then I can think of giving you the question related to that. Okay, let us try. Yes, you are sending only one frame at a time. True. I'm not giving you options. Now we'll have to make your hands dirty. Take a pen, pencil. Try to solve this. And I know that at least, half of you will be able to do it. If you're focused and if you try to solve it, you should be able to do it. Take time, don't worry. Okay, one more thing. See, whenever it is written Mbps, if this B is small, you will consider it bits. If this B is capital, by chance, most of the time it wouldn't be, but in case if it is B is capital, you will understand that bytes. Similarly, whenever B is capital, that is for bytes. If it is small, then it is bits. And whenever you're going for any question related to, CO or processor or computer networks, whenever speed is talking about or whenever memory is involved, then you will always be careful about bits and bytes conversion. Otherwise, even though you have done that correctly, that your answer will be incorrect. And this fellows are very smart who set the paper that always that incorrect answer would be part of the possible options. So you will feel that, okay, who got the correct answer, and you will write it. And always, go for the units. Units should be unified. Like if it is milliseconds, then always go for milliseconds. If it is seconds, then always go for seconds. And then try to solve it. Okay, please continue. Do not search about this. Try to do on your own. When I say round trip time is 45 milliseconds, what do you understand by that? Yes, divide by 2, that is one time propagation delay. So on the one time propagation delay is known as the time which you are taking to reach from transmitter to receiver. So that will be 22.2 milliseconds. In one direction we are consuming that time. If nothing is given, you will assume symmetric link and we will divide it by 2. It is possible that your packet might be consuming 25 milliseconds in the forward link and 20 seconds in the reverse link. But we are not going to get into these details unless it is mentioned. Please try to calculate it. Okay, let me give you a hint. How much time will you need to transmit the frame? When I say transmit the frame, currently I mean by that is how much time you require to put the frame on the channel. See, let us assume that if I say that when I'm sending a frame or a packet, here it is given that it is of 1000 kilobytes. That means 8000 bits I'm putting over the link. I'm putting 8000 bits. So it will not be done in 0 second. Like all the bits are not sent together. Always in the real life, the communication channels will be serial. Like most of the times, 90%, more than 95% of the time, it will be serial communication only. So you're putting the first bit, then the second bit, then the third bit, then the fourth bit, then the fifth bit. That means some very small, negligible, finite amount of time will be consumed when the last bit is put over the channel starting from the first bit. That is the time which we are consuming to put our data on the channel. Are you with me? Do you understand that? Like it is not so that in, like if I say send frame, then you are sending this frame at the 0 second. In 0 second, entire frame will not be put on the channel. I'm not saying transfer as in to reach the receiver. We are not talking about that. We are talking about the time which we consume to transmit it, just to put it over the channel. So here bandwidth is given to you and size of the packet is given to you. Based on these two parameters, you should be able to count that how much time you will be consuming to put the frame or the packet over the communication link. Please try it. Okay, what is the meaning of bandwidth? It says that in 1 second, we are able to send 1.5 into 10⁶ bits. Is it okay? Does this statement make sense to you? Okay. Then, should I be able to say that okay? Then, can you find out and when I said this in other terms, I'm asking you, yes? So now tell me, what is the correct answer? Dev, would you please like to see whether your answer is correct or Priyanks or channels? Yes, Keval. We have to check how much time we are going to consume for 1 kilobytes. Okay. That means I'm using the term packet here because in the question packet is given. Packet or frame doesn't matter. Now, oh, please ask me if anyone is having any question in this. Is it fine so far? Everyone, have you understood this much? That 5.33 milliseconds I'm consuming to keep the entire frame over the link. Is it okay with everyone? I'm saying the same repetitive names. Anyway, so now, which is the other parameter? Once you have put the frame over the link, it will take the propagation delay or the link delay. What is the delay? How much time it will take to reach to the receiver? It will not be reaching in 0 seconds. It will be taking some finite time. And it is very well given in the question. How much time it will be taking to reach the receiver? Why don't you do it for me and tell me, Bhavin? 22.5 milliseconds. Yes. So the first bit will be reaching at 22.5 milliseconds. The last bit of this first frame that will be received, or I can say the entire frame, first frame is received at, can you tell me what it would be? Isn't it? Right? The entire one will be received, the receiver receives the first frame at this point of time. So transmission delay plus propagation delay. Okay. This is a transmission delay. Transmission delay plus propagation delay, that time will be consumed by the frame to reach the receiver. So now can you try to think about the efficiency? So what is meaning of that? After this much time it is sent, and we are assuming that the reverse link is having the acknowledgement. Acknowledgement is not of the 1000 kilobytes, it is tiny acknowledgement. So transmission time or transmission delay for the acknowledgement is ignorable. So this much time is in the forward link. Then how much time will be required in the reverse link for acknowledgement to arrive? Come on. Yes, 22.5. True, very true. All of you are right. That means the first frame has been completely delivered. A transmitter knows about the status of that. After which time, transmitter ensures that the data has been delivered. Yes, tell me. Yes, very true. That means then it will be able to start the transmission of the second frame. It sends first frame of 1 kilobytes, and then the next frame, second frame, will be sent starting from 50.33 milliseconds. Are you with me? Okay, now we have to think about the efficiency. Like transmitter waits for 50.33 milliseconds to send one frame, out of which how much time actually is done by the transmitter? This much only. Your transmitter is busy for how much time? 5.33 milliseconds only. Otherwise, it was waiting for the acknowledgement to come and data to be delivered, etc. Transmitter was effectively used for 5.33 milliseconds from this. So can you tell me what could be the efficiency? Yes, true. Approximately 10.6. Between 10 to 11. 10.6 or efficiency is equal to 10.59 or 6 or whatever you are calculating here. So now, how can we improve the efficiency in stop and wait only? In stop and wait, you are going to send only one frame at a time. How can you improve the efficiency? 1. Your propagation delay should be reduced. Take the lower delay path. If this is reduced, then your efficiency will be improved. Do you agree with that? Yes. In the other parameter, we might also be worried about improving the bandwidth. Yes. But the mature parameter here, or the rather more affecting parameter, in my opinion, would be the propagation delay than the transmission delay. Isn't it? Okay. So we said that, highest efficiency of stop and wait protocol will be 50%. But in this scenario, it is just this much percentage. And here we are assuming that there are no retransmissions, there are no losses, nothing. Everything is fine. But then if 45 milliseconds is the round trip time, in one way, if you are consuming 22.5 milliseconds, then that much time is consumed. So now everyone be attentive for 1 minute, and then we are going to end it. Whenever this question might be asked in various ways. So this question, those who have taken the gate, they will realize that it will ask in the different context, that how much time you will be taking to reach the receiver. That was the question. So always you will first calculate the transmission time, that how much time we are going to consume at the transmitter to put your data over the channel, and then how much time your channel will be taking you to the other end. You will be summing them up, and that will be the delay in 1 second, one way. If it is asked in 2 ways and accordingly you will do it, then it could be the efficiency, or it could be some other parameter which can be derived from this. But whenever data is sent, then always at the transmitter, and that is defined, that is determined by bandwidth as well as the packet size. If the packet size is smaller, then the transmission time will be smaller. If the packet size is larger, obviously it will be longer. And then another parameter is propagation delay. Are we clear with this? Okay. Thank you.